So now we just have to answer a couple questions and we're done. So the condition for the block to stay in place or slide down the inclined plane depends on that relationship between the component of the weight in the perpendicular direction, which is this way, versus the component in the parallel direction, which is this way. If too much weight is in the, well, too much is in quotes because of course it might not be too much, but if it's in the direction that's parallel, then the block's going to slide down. But how much is too much? And that depends on how rough the material is, because you have this thing called a coefficient of friction, and rough materials are going to have a large coefficient of friction, sandpaper, that kind of thing, right? Whereas glass wouldn't have a low coefficient of friction. So we're going to suppose that our coefficient of friction in this particular case, and here's mu right here, don't lose it. That's mu, by the way. It's a Greek letter. It's at the M sound if you're ever in Greece. All right, so our coefficient of friction for our particular problem is going to be 0.65. So let's see if it's going to slide or if it's going to stick. All right, so the magnitude of W, the weight, in the parallel direction was 100 sine of 20 degrees. Is that in fact larger than, so I'm going to find both of these and I'll find out if it's larger. 0.65, because that's my mu. I'm just going to put this with a little question mark over it because I don't know if it is bigger. And then my component of my weight in the perpendicular direction was 100 cosine of 20 degrees. All right, so I just need to find these two pieces and see if they're bigger than each other. Easy enough. All right, so let's go to Maple. All right, I'm going to make a new section. I'll call it example 7. All right, so let's find that angle. I'm going to name the angle A7 colon equals. I'm going to convert because, of course, Maple doesn't really like degrees. So I'm going to convert it from degrees to radians. So 20 degrees to radians. There. Now I have that angle done. And let's face it, I don't really want the pi part. I want a decimal. So I'm going to put a decimal in right now, and that way it knows I want a decimal. All right, so what I want is 100 sine of A7. And then I want 0.65 times 100 cosine of A7. And there we have our two values. Oops, let me make this larger so you can see. So the question is 100 sine of A7, which is 34.2, greater than 61.08, which would be the right-hand side? And of course, the answer is no, right? It is not greater than, and therefore, right, this is false. This is a false statement. So therefore, the block will not slide. The force that was in, or the amount of the weight that was in the parallel direction was not enough to compensate for this friction coefficient. Okay, so how could I get it to slide, right? How steeply can I incline the plane before that block is going to slide? So let's think about that for a second. We want the block, or we want to think about this block right here. This is our angle theta. So it's going to slide when the coefficient of friction, right, is greater, right? Okay, so what is this? Let's look at that. What's the W in the parallel? And then the W in the perpendicular. Let's think about those for just a second. So this would be 100 sine of 20 degrees. Oh, sorry, of an angle, right? That's the point. We don't know the angle. So that's fine. Angle theta. And then this would be 100 times 100 sine of that angle. So what they're asking is, hey, what would the angle have to be? So if I want to solve this for mu, and that mu is 0.65, I want to divide both sides by 100. Oh, yeah, 100. I just did that. Hold on, the perpendicular is cosine. grief. I was so busy thinking about the mu that I forgot. All right, so divide by 100 cosine of theta. Over here, this is all going to go. And over here, the hundreds are going to go, and you're left with sine of theta over the cosine of theta. So we need the sine of theta over the cosine of theta to be greater than whatever mu is. But that's the tangent of theta. So if we can get the tangent of theta to be greater than mu, the block will slide. Now let's use our particular example. Right? We want, I'm just going to put a box around that. Okay, so for our example, we want the tangent of theta to be greater than 0.65. So that would mean that theta has to be greater than the arctangent of 0.65. So we are going to stick that into Maple and make Maple find it. Okay, so the arctangent of 0.65, all right, it's giving it to us, of course, in radians. So if we want to convert, we can tell it, hey, that's fine, you gave it to me in radians, but I want you to convert that. So convert that answer, which is 4.4. So I'm going to insert a label and tell it to take answer 4.4 and convert that to degrees. And then it will do it. And it's 33 degrees, roughly. All right, so we have our answer. Theta would have to be greater than 33 degrees. And along the way, we actually learned another formula right here.